Today I'm going to be covering the derivatives of natural logs. First, let's look at the rule itself, which is really composed of two rules, one for the simplest case and another for the more general case. The simplest case shows what the derivative of just the natural log of x is, while the general case shows what the derivative of a natural log of a function is, much like our previous chain rule, which we also called the general power rule. So the derivative of the natural log of x is just 1 over x, and the derivative of the natural log of a function of x is 1 over that function multiplied by the derivative of that function. Often, this second rule is simplified to become the derivative of the inside function over the inside function, or f prime of x over f of x. But the first version has the benefit of seeing that these two rules are really just the same. You can see in the blue that in the simplest case, it just happens to be that the derivative of x is always 1. So if x is our entire inside function, we can ignore the chain part of the chain rule, and it becomes the simplest case. Note here that ln actually stands for natural log, otherwise known as a log function with base e. I may refer to ln as log and this derivative rule as the log rule in this video for the sake of simplicity. But to be clear, this is the derivative rule for natural logs, though it is very unlikely that you'll see logs of a different base in this class. Another quick note is that exponential and logarithmic operations are opposites that undo each other, like multiplication and division or addition and subtraction. This isn't crucial to understanding the derivative rule, but it can help you better understand how these functions work and why you typically learn the exponential and log derivative rules together. So let's go through an example. If we just see the simplest case of the natural log of x, we should immediately know that the derivative is 1 over x. You can still get this answer the long way going through the steps of the general case rule, but it's easier to just memorize this since it's a specific case. If we have a constant attached to it, then we just use the constant multiple rule and recognize that it will be the constant multiplied by 1 over x. Most of the time you'll need to use the general rule though, so let's take a look at some examples of that. Here is an example where we need to use the more general case rule. You can also call this rule the chain rule for natural log derivatives if that makes more sense to you. The first step is to match our function to the pieces of this rule, which you can see here illustrated by the colors. The second step is to identify the inner function, which is the f of x part in our rule, and find its derivative. The third step is to put those pieces in the order that the rule describes, so the derivative of the inner function divided by the original inner function. And that's all there is to it. We can simplify and clean up the result if we have constants that can be combined or distributed, but there's nothing here to clean up, so we're done. Now that you know how these rules work, pause this video and try these two practice problems on your own. I've also included 2 challenge problems that you can try. The first challenge problem requires using the general power rule, and the second one requires the use of the product rule. I'll reveal the solutions for all of these momentarily. So here are the solutions to those practice problems. That 3-step process is very helpful when you're learning the basics of derivatives with natural logs. But as you get better, you may find yourself doing the steps more quickly or combining steps, and that's perfectly fine. Or if you want to choose to always use this 3-step process, that's perfectly fine too. Whatever works best for you. Here's the solution to challenge problem 1. If you had any issues, you can pause the video here and look at the different steps for the solution. Here's the solution to challenge problem 2. Note that here everything is in terms of s, so wherever we would normally put an x, we've put an s instead. But really, just as long as the s appears in your solution, it doesn't matter if s is in the notation or the intermediate steps. If you had any trouble with the challenge questions, you can check out the video on complex derivatives, which goes into more detail on how and when to use multiple derivative rules in a single problem. Thanks for watching.